Hello, welcome to our Solve Problem series, and in this video we are going to prove a trigonometric identity. So as you can see on the screen, it says prove that tangent x minus cotangent x over tangent x plus cotangent x is equal to -1 plus 2 sine squared x. So how do we prove this identity? So we will be using the left hand side approach because as you can see on the problem, the left hand side is more complex than the right hand side. So that's one of the key ideas when you decide or when you think about how to prove a certain identity. You have to look at the two sides and determine which one is more complex. And you try to simplify that and do some um, changes or substitution in terms of identities until you reach the expression on the other side. Okay, so we will start our proof by stating, so this is our proof. So first thing to do is we copy the left hand side, so we can write LHS here to indicate that we're doing a left hand side approach. Well, it's just a name. Okay, so minus cotangent x over tangent x plus cotangent x. So when you prove identities, think about the identities that you have learned or that you know. And at the same time, a very common approach to proving identities is to convert some functions into sine and cosine. Okay? As you can see from the right side, the expression only contains sine. So we must find a way to change this tangent and cotangent into an expression that will only contain sine. But probably along the way we will need some other functions like the cosine, because as we can see, tangent is related to sine and cosine. So I need you to review some identities, and when proving this given problem, you should know that tangent x is equal to sine x over cosine x. So there are things that you need to know when you prove identities. You cannot just um, attack and prove an identity without some prior knowledge of basic identities. Now, cotangent x, on the other hand, is the reciprocal of tangent, meaning to say it's 1 over tangent x, which simply means it's the reciprocal of sine x over cosine x. So cotangent x is basically cosine x over sine x. So what will you do now is, with this expression that you have here, change all those tangent x and cotangent x with their respective identities. So our step 2 will basically become sine x over cosine x minus cosine x over sine x, and then you have the fraction same sine x over cosine x plus cosine x over sine x. Now don't be tempted to cancel those tangent and cotangent and cotangent, because you cannot do that. Okay, there's a minus sign and there's a plus sign here, so canceling those tangents and cotangents will not be applicable. Okay, so once you reach this step, normally when you see fractions in trigonometric expressions, to simplify them is to combine them. So focus on the numerator. We'll be combining this into a single fraction, and that's by LCD. The LCD is basically the product of the denominators because they are different. So that's cosine x and sine x. And then work on fractions. So you should know how to combine fractions. So cosine x over sine x times sine x divided by this cosine, that will cancel the cosine. So you have sine x times sine x, that is sine squared x. In the same way, if we will be dividing the LCD by sine x, the sine x will be cancelled. So you have cosine x times this cosine x. So you have minus cosine squared x. And then, so that's only the numerator. So we have to work on the denominator. And if you look at it, the expression is very similar, except that the sign in the middle is a plus sign instead of a minus sign. So that means if we will be combining those two, we will get sine squared x, but this one is a plus cosine squared x. Now as you can see, so sine squared x minus cosine squared x over cosine x sine x. Then you have sine squared x plus cosine squared x over cosine x sine x. So these two will immediately be cancelled. Cosine x sine x. Or you can do the long way of inverting this denominator, so changing the division into multiplication of the reciprocal over sine squared x. You can also do that. So totally replace this by multiplication of the reciprocal, and as you can see, these two will cancel now. So we can do cancelling because there is no addition and subtraction involved. Okay, you have a multiplication here, so cancellation is allowed. Now, so looking at the remaining expression, you have sine squared x minus cosine squared x over. So I think it's best if we write that down so that you can see what happened after the previous step. Sine squared x plus, this is minus, plus cosine squared x. That's the resulting expression after we cancel cosine x and sine x. Now this is an identity. You should know this. This is equal to 1. So if this is 1, so we can write it down so that you can show the step by step, because that is needed in proving. You have to show the step, all the steps. Okay, so over 1 now, but dividing by 1 will result to the same expression. So we're almost there with our goal. Our goal is to get negative 1 plus 2 sine squared x. This is our goal. The problem is, we have that sine squared x, as you can see, but we have this cosine squared x. So we have to look for an identity that will replace that cosine squared x into a sine. And we know one that can do that. Sine squared x, this is the same identity that we used in the previous step, is equal to 1. That is why this became 1. So if sine squared x plus cosine squared x equals 1, then cosine squared x is equal to 1 minus sine squared x. So this will take the place of cosine squared x, making it now sine squared x minus, so close it in the parenthesis because it's a group of expressions, minus sine squared x. And then you have sine squared x. Outside the parenthesis, it will transform in this way, and then adding the sine squared x and sine squared x, that's 2 sine squared x, and the minus 1 will remain as minus 1. And if you look at the problem again, that's exactly what we need on the right side. Therefore, we were able to prove that it is an identity. So we can end our proof by just putting a shaded square indicating that the proof has ended. Okay, so what will be your take home for this video? This is just one of the many proving identity problems that you might encounter, but the key ideas in this example is that you should know Number one, you should know some fundamental identities like tangent x is equal to sine over cosine. Cotangent is 1 over tangent, so that's cosine over sine. You have sine squared x plus cosine squared x is equal to 1. And you should know how to manipulate that to create a new identity. That's how we replace the cosine squared x. And then along the way, we use them. The idea was to replace those tangent x and cotangent x with sine and cosine. You simplify fractions by combining them. Take a look at some expressions that you can cancel. Simplify further until you reach the expression that you need. Proving identities is more of trial and error because there are times when you substitute some values and it won't work. So that means you have to find a different way or different approach or different identity maybe in proving the identity. Okay, so that's all for this video. I hope that you learned something from this. Okay, and that's it. Okay, thank you for listening.